What you're going to learn today is how to go from an equation to creating something on a coordinate plane, creating a graph. So let's get started. Here's the question you're given. Create a function table for f of x equals 2x minus 1. Use the ordered pairs to graph the line. Well, what exactly does that look like? Well, the first thing we have to do is we have to create a table. Creating a function table is the same thing as creating an input-output table for the function f of x equals 2x minus 1. What I need to do is I need to pick numbers that I want to put in for x. And I can pick any numbers in the world, but what I want to do is I want to pick numbers that are easy to do math with. So I'm going to choose 0, 1, and 2. Alrighty, and then I'm going to do 2 times 0 minus 1. That gives me a negative 1. 2 times 1 minus 1, that should give me a 1. And 2 times 2 minus 1 equals 3. And if you're thinking, where in the world is she coming up with these numbers? Right here, that's exactly where I'm coming up with the numbers. The next thing I need to do is make some ordered pairs. The ordered pairs are just the x and the f of x. So this is a 0, negative 1. This one is a 1, 1. And this one is a 2, 3. Now I'm ready to graph those points. Okay, it's time to plot these points. So 0, negative 1 is here, and 1, 1 is here, and 2, 3 is right here. The next thing I need to do is draw a line that connects those three dots. All right. It is always good when you draw a line that you put arrows on both sides, because basically this equation represents a line that goes on forever. The other thing that I want you to do is make sure that when you do your line, you go all the way through the graph. Don't just put the line at the three dots and call it done. All right, let's go on to another one. Here we have the function negative 4x plus 5. So I can start with the same three numbers. I'll keep using those numbers until it stops working for me. So this time I'm not going to write the equation to the side because I'm going to leave room for the ordered pairs. So we're going to do this mental math. Negative 4 times 0 is 0 plus 5 is 5. Negative 4 times 1 is negative 4 plus 5 is positive 1. And then negative 4 times 2 is negative 8 plus 5 is negative 3. So my ordered pairs are 0, 5, 1, 1, and 2, negative 3. Next thing I have to do is plot the points. So 0, 5 goes here, 1, 1 here, and 2, negative 3 goes here. All right. When making a line, make sure that you have a straight edge so you can make a nice straight line. Or if it's on the computer will do the line for you. And again, don't forget to put your arrows. All right, let's see if you can do the next one on your own. Try this for a minute on your own and see if you can get it or if you run into some issues. Pause the video and then come back. All right. Did you use 0, 1, and 2 like I have? Did you run into any problems with that? Well, if you did use those numbers, you would have got a 0 here, a 1/3 here, and a 2/3 here. And you might have been thinking, how am I going to graph that? I mean, those numbers are on the graph. Don't get me wrong. It's just that it's really hard to estimate where 1/3 and 2/3 are located. So let's try numbers. The 0, 0 is fine. But let's try some numbers that maybe are a little bit easier to graph. So I'm going to do my 0. And then I'm going to choose the denominator. That's an easy one to do. So I'm going to just choose the 3. And then I could do the negative version of that, which actually is probably a really good idea. Or I can just do the next multiple of 3, which is a 6. So which one would you like to do, the negative 3 or the 6? Well, if you're like my students, you're going to want to say the positive 6 because many people do not like the negatives. So we'll go ahead and do that. So 1/3 times 0 is 0. 1/3 of 3 is just a 1. And 1/3 times 6 is a 2. See how nice that worked out? So here are my ordered pairs. And 6, 2. Alrighty. 0, 0, 3, 1, and 6, 2. All right, time to line up my ruler here. Voila, there we go. And you know what? Had we chosen the -3, let's just look at this for a sec. If I had done the -3, then 1/3 times -3 would have given me a -1, and I would have had a point here. So the question is, did the line go through that point? Certainly, it sure did. It doesn't matter what numbers you put in for x. For this equation, they should all land on the same line. All right, let's do one more, and I am going for the hard stuff. So again, 0 probably works really well in here. So I'm going to put a 0 in there. And then, see in my fraction, do you remember the hint I gave you on the last fraction? Use the denominator as one of the numbers. So I'm going to use a 5. And let me go ahead and do that before I do the last one. So 1 minus 4/5 times 0. 4/5 times 0 is just a 0. So 1 minus 0 is just a 1. Remember, you still have to follow order of operations. So I have to multiply my 5 times the 4/5 before I do the 1 minus. So 4/5 times 5 is going to give me a 4. So I have a 1 minus 4, which is a -3. Now, I could put the next multiple of 5. I could put a 10 right here. But do you see a problem that I have if I put a 10 right there? 10 is not on my graph. So it's like, okay, can't do that. But what about doing what we did on the other one and choosing the -5? Alrighty. So we're going to go up there, and I'm going to actually use the word negative when I say 4/5. So -4/5 times -5 is going to give me a +4. And so 1 plus that 4 is going to give me a 5. All right, let's graph that. 0, 1, and 5, -3 down here. And then -5, 5 all the way up here. Now, if they don't create a straight line, then you should look at it and go, there must be some problem here. But these are going to create a straight line. They're doing really well. All right, so that's how you create a function table, and that's how you create a graph from the function table. All right, go and have some fun.